Welcome friends, let us continue our discussion on transient response. We have solved one problem. We shall discuss this topic on few more problems. Okay, so let us consider this figure 9. Let us consider this figure 9. It refers that the switch is initially placed at position 1 for a long time. Now this statement you will often find in this type of problem. The initially placed at position 1 for a long time. This for a long time, when it mentioned, when you get this term for a long time, it immediately you can understand it refers steady state. It refers steady state. That means at this position 1 the switch is placed in this fashion. That means this 12 volt source, this circuit will be looking like is simply this. It is a series RL circuit, simple. One Henry, some current is flowing IT. Now when the switch is placed at position 1, let us say this is position 1, for a long time, that means it is operated for a long time, so the circuit reaches at steady state value. Now when the circuit reaches at steady state value, then that inductor, from the property of the inductor, we can understand that it offers zero resistance because it is acting as a short circuit. So we can say that I0 minus, that will be equal to 12 by 4, that is 3 ampere. That means just prior of the switching, you follow the next statement, after which the switch, it is placed at position 2 at t is equal to 0. That means switch is placed from position 1 to position 2 and switching instant is t is equal to 0. That means just before the switching operation, when switch is placed at position 1 for the last instant, that means at that point inductor behaves like a short circuit and current flowing through the inductor will be 12 by 4, that is 3 ampere, and due to the property of the inductor I0 plus, that will be also 3 ampere. So I0 minus, that will be equal to I0 plus is equal to 3 ampere, right? This is the initial condition. So we have equation. What is the equation for now? Switch is placed at position 2. Switch is placed at position 2. Now after making the switch at position 2, the circuit will be looking like this. This is 48 volt, this is 4 ohm and this is 1 Henry. Now this is at position 2. Okay, this is at position 2. Now it is just switch is placed at position 2 at t is equal to 0. So we want to calculate current flowing through that resistance. So as it is done at t is equal to 0, switching has been done at t is equal to 0, it refers as transient state. So if we write the KVL equation, we have 48 plus 4 IT plus 1 di dt. So immediately we draw we can write the solution for it. IT equal to, if you refer this differential equation, this one, dy dt plus ay is equal to b. Here a is equal to 4, b is equal to 48. Here a is equal to 4, b is equal to 48. Yes, we have a is equal to 4, b is equal to 48. So immediately we can write the solution. It will be b by a plus a into e to the power minus t by tau. It is b by a plus k into e to the, plus k into e to the power minus 80. Sorry. It's my mistake. It is k into e to the power minus 80. So let me write down the equations. It, that is equal to b by a, that means 48 by 4. 48 by 4, that means it is 12 plus k into e to the power minus 40. So it is equal to 12 plus k e to the power minus 40. So this is the equation. Now you need to evaluate k. For that, so here you see we have solved it is equal to 12 plus k e to the power minus 40. Now using initial condition at t is equal to 0 plus, we have I 0 plus is equal to what? I 0 plus is equal to 3 ampere. So we can substitute that. So if you put I is equal to 0, so t is equal to 0 here, so I becomes 3 ampere. So 3 is equal to 12 plus k into e to the power minus 4 into 0. So this becomes 1. So k becomes 3 minus 12 is equal to minus 9. So k becomes minus 9. So your overall answer becomes it, that will be 12 minus 9 e to the power minus 40. That is your answer. So this current, when switch is placed at position 2, this current will become 9 minus 12 minus 9 e to the power minus 40. 12 minus 9 e to the power minus 40. That is the solution for this current. So primarily what we have discussed till now, that transient response of series RL, RC, RLC network under DC excitation. Now we can have also AC excitation. Okay. So in this case, till now we have seen the responses under DC excitation. Now from the next session we shall see the transient behavior in under AC excitation, when the series RL or series RC circuit is excited under AC excitation, then how that network behaves. So and then we will solve more problems on that. So till now we have primarily understood the main concept of inductance and capacitance under transient condition and steady state condition, and from there we have understood the nature of the current waveforms and voltage waveforms under different conditions. We have also understood the concept of damping and different types of damping existing in the electrical system, and we have also solved 2 problems or to demonstrate these concepts. So with this I am ending this session here. From the next session we shall discuss this transient behavior under AC excitation. Thank you.